Okay, class. For the batch kinetics, okay, in batch process, okay, for bioprocess, sometimes the concentration of substrate might be introduced at different value of concentration for certain time. Okay, therefore, the plot of 1 over T ln S naught initial concentration of S over S, okay, the value of S at that particular time, okay, versus S naught minus S, okay, over T. Okay, from this graph, you may able to identify the value of Km and Vm from the slope and the Y interception. Okay, so from the slope, you can find the Km value. Okay, the slope will give you the negative slope, because this graph will the graph is in the negative linear graph. Okay, and if you already have the value of Km, then by using the value of interception, okay, you may able to find the value of Vm. Okay, so for the Km and Vm, because these two are the most important kinetic parameters in the enzyme reaction kinetic. Okay, so Vm is dependent on the enzyme concentration, right? And Km is the function of rate parameters and expected to change with temperature and pH. Okay? And the unit of Vm is the same as the reaction rate. Can be moles per liter per minute or gram per liter second. Okay, moles per liter minute. Okay, alright. Km is a measure of the affinity of the enzyme for substrate. Okay. At low Km value, if you find the Km value is low, okay, this is where in the case of we are making a comparison between two data, then if one of the data is low, so the Km value is low, so it indicates that, okay, the lower value of Km indicates the tight binding of the substrate by the enzyme, okay, whereas a high Km, okay, it indicates a weak binding. Okay, it is a very useful measurement, okay, to be used, okay, of the relative strength of the binding of an enzyme for different substrate. If we have different substrate, it means that we have different data we want to compare. So based on the value of Km, we may able to make the comparison. Okay, a small Km also indicates that the enzyme requires only a small amount of substrate, okay, to become saturated. Okay, therefore the maximum velocity is reached at relatively low substrate concentrations. Large Km, it indicates the need for higher substrate concentrations in order to achieve a maximum reaction velocity. Okay, the Km is independent of the enzyme concentration. It is more dependent on the substrate concentration. Okay. Okay. So the unit is the amount of enzyme that give a predetermined amount of catalytic activity under specific condition. Okay, unit. We always found this word when it is mentioned on the concentration of enzyme. Okay, so the concentration of enzyme, it can be in the unit of unit. That's the unit. Okay, alright. So the turnover number of the enzyme, which has been mentioned in the previous presentation, Okay, this K2, which is equivalent to Kcat, okay, Kcat, okay, K-catalytic is also known as the turnover number of enzyme. So it's a number of the substrate molecules that are converted into product, alright, by the enzyme, okay, per unit time. Okay, means it is a reaction rate lah. Okay, when it's fully saturated with substrate. Okay, so the turnover number of enzyme K2 equivalent to Kcat is the number of substrate molecules that are being converted into product, okay, by the enzyme per unit time when it is fully saturated with substrate. Okay, and the equation, in order to find the value of Kcat, okay, you can use this equation. Alright. Okay. So let's see. Okay, specific activity is the number of unit of activity per amount of total protein. Okay. Alright. Talking about the turnover number, this number, it can vary between enzymes, another enzyme, one enzyme to another enzyme. Okay, so the rate at which an enzyme works is not dependent on how tightly the substrate binds. Okay, it can also relies on the turnover number. It means that it's not only depend on the Km value, but it also relies on the Kcat value also. Okay, so that is a method where we can use in order to make a comparison of a set of data in the enzyme reaction kinetic.